After all of the data has been collected from approximately 6 titrations, we can analyze the data. In part 1, we pipetted 25 milliliters of potassium iodate, and the potassium iodate is of a known concentration that is given. We add excess iodide and excess acid to produce iodine, 3 moles of iodine. The iodine is then titrated with 2 moles of sodium thiosulfate. For every 1 iodate, we produce 3 moles of iodine. And then for every mole of iodine that we have produced, we can calculate that amount and titrate it with 2 moles of sodium thiosulfate. We do not know the concentration of the sodium thiosulfate, but our analysis can help us derive that value. We will have the volume from the titration that we read from the burette. So to start our calculation, we take the 25 mils of iodate, convert it to liters for 0.025 liters, and multiply it by the given concentration of iodate. We produce 3 moles of iodine for every mole of iodate, and we use 2 moles of sodium thiosulfate to react each mole of iodine. This gives us the moles of sodium thiosulfate used during the titration. To determine the concentration of the thiosulfate, we can use the volume from the titration. So the molarity of the sodium thiosulfate is found taking the moles we calculated and dividing by the liters used in the burette. Remember, we read milliliters from the burette, but we must convert it to liters to use it in the calculation. This will be done 3 times to find an average value for the molarity of thiosulfate. Moving on to part 2, we can calculate the amount of iodate in our saturated solution. The reactions are the same, only this time we are pipetting 10 mils of calcium iodate from the saturated solution, and we do not know its concentration. We will add excess iodide ions and excess acid, and again it will produce iodine, and that iodine will be titrated with the sodium thiosulfate. We now have the average concentration that we determined in part 1, and we will still read the volume from the burette. So to start this calculation,